14 Geological Geometry question C1 for the higher level. Okay, so we have a golf course. We have the map, okay, with all the information here. Side slopes, and we have then a profile to draw, and then we have to draw the path of the golf. Okay, so have a look at that now. Okay. Okay, so we just bring the noise level down a wee bit so I can do this video. Okay, so we have our map here now, and what we're looking at is we have a fairway. Okay, the contours are 5 meters. The fairway between level A and B is level at an altitude of 75. So I'm going to put that on the map. That's 75 meters. Okay, the putting green is also level at an altitude of 75. The section of the fairway from B to C has a gradient of 1 in 20 rising, which means for every 1 meter you go up, it means that you've travelled along horizontally 20 meters. Okay, rise over run from your maths. And using side slopes of 1:1 for cut, and 1:1.5 for fill, complete the artworks on the map. Okay, so we'll apply these to the map and we'll get this part done here. So the first thing that we need to figure out is we need to step out from the arc. We're going to work left to right. It's at 75, this is at 75, so we're talking all these contours are below, so therefore it's going to be a fill activity. So we're going to have to fill in first, so we're going to use our fill ratio. So the spaces for fill, if I just write it in here, fill is equal to 1:1.5. Multiply that by 5, giving us 5:7.5. Our spaces are 7.5s. So if I step out from this arc of 7.5 and 15 and 22.5, 30, that should be plenty of arc. So from the center,
and here we connect two dots, one input and then this start.
okay, and what we'll do then is from the edge of the road we'll step up the same. So we'll go 7.5, 15, 22.5, 30. I'll draw these in red. We know that it meets the 75 contour there. So for our fill, if 75 is where you're not doing any work, then 70 is going to be the next, 65, 60 and 55. And what we'll do then is we'll put in our points. So where this line meets the 70 contour, put in that first one, then 65, then 60, then 55. So our map will go something like this, and for the curved section we're going to have the same numbers associated. So the green is at 75 meters above sea level, and as we come out it's going to reduce in numbers. So it's going to be 70, 65, 60, 55. We'll probably have to go to 50. So 70 doesn't cross 70, 65 crosses 65 here. Where's my green pen again? 65 crosses 65 there, 60 crosses 60, 55 crosses there. And I've got as far as 55. So I'll add 7.5 onto this. Draw my arc. And so that's associated with the 50 contour. And so where that crosses 50 will be here and here, and then come back to 55 there. And it crosses 60 contour here, crosses 65 there. So for the curved road, curved section, we have that. So we have our overlapping lines, which is perfect, and then that can join straight up to there, given this is the flat section and that's the curved section of work. If we wanted to just to highlight it again for practice, it doesn't have to be done for exam, we can always make things easier for the examiner. Therefore might have a reflection on your score, your mark, make things easier, make things clearer, show off your knowledge. That's what we are going to be filling in. So then we're going to go for this section here, and this is going to be our cut section. And the ratio for that, for the cut, is 1:1. We need to multiply that by 5 because the contours are in 5s, and therefore the spaces will be in 5s. So, here's my blue. I'm going to step out in 5s. These contours are going to be above. So the next one will be 80, 85, 90, 95. And again, wherever they meet this corresponding contour, we'll mark them in. So the 80 meets 80 here, 85 meets 85 there, 90 meets 90 here and here. Then we're back down to 85, then we're back down to 80, and then back down to 75. So that there is the cut activity. And just for clarification purposes, again, we're just going to put that in blue for the 10 seconds it takes to shade it in. We're almost symmetrical as well. Okay, the land is going that way, so you're obviously going to have the higher section is going to be in line with that. So that's looking pretty good. Now, this section here from B to C is where we have the fall, okay? Or sorry, the rise. So it's 1 is the 20 rising, meaning, guys, we'll take the noise down, please. Okay, thank you. Okay, which means in every 20 meters you've walked along horizontally, it means you've gone up by 1. So therefore B is at 75. I need to walk away in a multiple of that, and the furthest away from me is 100 millimeters. Okay, which means I've multiplied, so 1 is to 20. I've now changed that into 100. 20 goes into 100 5 times, which means I've changed the first number by 5, which means I've gone up 5 meters from where I started. Okay, so therefore if that was 75 meters, when I get to this point here, I'm then at 80 meters above sea level, and we're going to call this point D. Okay, it's not exactly where C is because you have to find the distance, and on the map, if you notice, I'll step away. And that's my point there. Bring that out to the edges of the road. And that line there is 80 meters above sea level. Okay, so what we're going to do now is we're going to do assess our work. So see what the maps and the contours are and see what work I have to do. Is it a cut or a fill arc or cone? So here at B, this is 75. The contours then come below it, and at no stage do they return or get close to coming up to 80 meters. So the slope itself is always going to be above the road. Or sorry, the slope itself is always going to be above the land. So that's at 75 and getting higher and higher, and then this is at 75 getting lower and lower and then coming back again. Okay, so this section of fairway is always going to be above the land, therefore it's always going to be a fill activity. So if we take our red pen, okay, and do our fill activity, means we need a fill cone, and the fill cone occurs at the hill. So fill at the hill, cut at the butt. So our fill cone is going to be at the hill point over here. So now we need to work out the radius. So the height difference between the two spots, or the two locations B and D, is 5 meters. Okay, now our ratio for our fill is 1:1.5. So we multiply that by 5, because that's the height difference in both, and therefore our arc is going to be 7.5 in radius. So we will step out by 7.5. We will draw in our arc. So there's my fill cone. And I'm going to bring that back tangentially to my other location on the side of the road, which is B, 75. And that red line hits the road at 75, so therefore it's going to be associated with the 75 contour. Now we know from previous activity over here that our parallel lines should be 7.5 apart. Draw our parallel line to this tangent line. And it's a fill activity, so therefore the further I get away, the lower the numbers will go. So that's 75, this is going to be 70. This is going to be 65, 60, 55, 50. We'll mark in, and we'll actually just go one below this as well. So inside the line, so we'll go 7.5 to here. Parallel line to the original tangent line. One inside. And that's going to be 80, just in case it's needed. So 75 crosses 75 somewhere over here. 70 will cross 70. Here. Okay, if I continue that on. Now cross it there. Does it cross 70 contour anywhere else? It does. It crosses it here. 75 crosses 75 right there. 70 will cross 70. 65 crosses 65. 60 crosses 60 here. 55 crosses 55 there and there. Then we go back to 60. Then we go back to 65. And this is our curve for our fill activity with a sloping road. And again, it's almost symmetrical to the other side. That is our work there. Okay, so that's all of part A complete. Part B now asks, on the map provided, vertical boreholes, sorry, wrong one. Sorry, no. Part B says, in the space provided at the top of the map, draw a vertical section profile on the line DE after the artworks of ABC. So, we have our line DE, so all we need to do is bring up our points. Bring up D. So before we do that, actually what we're going to do is, this is at 65. I'm going to go in 5s, so 5, 10. 65, 60, 55, 70, 75, 80, 85, 90. Write these on it: 60, 55, 50, 70, 75, 80, 85, 90. We'll bring these up to the corresponding points. And across.
It's good. Yeah.
So we put in our dots here for this then. Okay, so we're starting here on 55. Then we go to 50. Then we go to 50 again. Then we go to 55. Then we go to 60. Actually, this point here, we need to bring that up, because that intersection there, we know this green is at 75. So we know that the green, we do it in blue, is 75. We know the green is that much. And the next point, this point is at 50, so therefore drop down, big drop. Alright, so this point is the green. Note that this point here then is untouched. This is at 65, so we can bring that up to 65. And this is 70. This is 75. Let's bring our lines that a little bit further. Forgot to bring them up. This point here is so there's your green. Don't forget that this slope here is a continuous slope till it gets to that point there. And that point is slightly above 60, so it's just gone a little bit too tall there. Slightly above 60. And it comes from there back to. Okay, so that's your continuous slope. So that's part B of the map. Okay, and it says end space provided on the line D after earthworks for the fairway ABC have been completed. So you have to include this fairway here and the green. Okay, so you have to include that flat slope at 75 and then the continuous gradient there, and then your slope of the land. So then the last point is a golf ball positioned at point E is struck in a westerly direction. So here's point E, it's going west. Okay, west will be that way according to our map. And the path of the ball is a parabola which rises to a maximum altitude of 115 meters, having traveled a horizontal distance of 100 meters in plan. So for example, from E, after it's traveled 100 meters to here, bring this up in red. So after 100 meters, it's traveled to an altitude of 115. If we put in all of our horizontal heights here, that'll be 95, that'll be 100, 105. Let's go two more, get to 115. So there's 110, there's 115. Okay, so that means that the ball has now travelled to here. So that's 110, 115. So after the ball is struck here, it lands up there in a parabolic shape. So we need to draw half a parabola. So what we're going to do is in red, we're going to draw in this rectangle. This is what we call our vertex. Okay, and we have 65 to 115. That's a 50 difference. I'm going to split this up into 50, so that's every 10 millimeters is every 10 millimeters means that it is a space. The vertical height is split up into 5 equal segments. So 1, 2, 3, 4, 5. And if we split the 100 millimeters up into 5 as well, you get 25. So we've got 25, 50, 25. 25, 50, 25, 50. Okay. So these will be verticals. And then these 5 points will go to the vertex. 1 goes to the vertex, 2 goes to the vertex, 3 goes to the vertex, 4 goes to the vertex. And these will be moving away, so this will be point 1, this will be point 2, this will be point 3, point 1, 2, 3, 4. It's supposed to be every 20 millimeters, apologies. Sorry, 20, 40, 60, 80. So I'm going to do these in blue. Sorry. Now, so that would be 1, 2, 3, 4, 5. 5 and 5 meet at the vertex, so we don't need to do anything for that. Where do 4 and 4 meet? 4 and 4 meet here. 3 and 3 meet there. 2 and 2 meet here. And 1 and 1 meet there. That gives us the path of our ball, of a parabolic shape. And then we have to repeat that pattern over to the other side. So what we do is we bring them over horizontally. We use our compass to double the distance. Just mirroring them across. Ball path continues down this way. So if this is our green, the ball will land here. Therefore, the ball will land there. So the question says, in the profile view, draw the parabola and determine the position of the point on the green where the ball initially lands. There and there. Okay? That's our question solved. That's the map. I hope that helps.